Hello everyone, I am Dr. Senthilkumar Selvaraj, working as the Assistant Professor in Department of Electronics and Instrumentation Engineering. So I completed my PhD in Robotics. Today we are going to discuss about the introduction to the robotics. So first, what is the robotics? So robotics is the whenever we need the automation like industries without any interruption of the human powers, we are going to create the automation. The robotics is very useful to create the automation, and then we just complete the manufacturing process and everything. So robot, first, what is the robot? So robot word, it came from the word robota. So the robota is a CZ, the word came. So what is means robota means? Robota means it is a servant. So servant, if you give the order to the servant, he have to obey your order and then he have to complete the task. So like that, if you give the order to the robotic model, automatically it will follow your commands and then it will complete the task immediately. So based on your programmer. So robot is the reprogrammable device. So you can change your program based on your application and everything. So once you're doing some work, and after that I have to change some grippers and everything. So based on that you have to change the program. So based on your program, the robot model, it will obey your order, and after that it will complete the task immediately. So what is the definition? The robot word, the first of all introduced Karl Kappa. So he's introduced the word of robot. So what is the robotic means? The robot is the reprogrammable multifunctional manipulated design to move material. That means the robotic model it will use to move the objects one place to another place, and then it will do lot of industrial applications. It will help like Puma and Scala. We have the different type of the industrial robotic models. So that robotic models we have two types. So this is the multifunctional manipulated designed. It will move the objects one place to another place. In manufacturing company, they are using the different type of the industrial robots. Like we have the material handling robot, and then we are just loading and unloading robot, spray coating robot, and lot of things. So we are using the different type of the robotic models in industries and manufacturing companies. Based on three laws, it will call that is the Asimov. He proposed the three laws. We calling that is the Asimov's law. So we have the three laws. The first one is the robot may not injure the human. That is the first law. And second law, a robot must obey orders from the human being. That is the second one. And third one, the robot must protect itself but don't break above higher laws. So that is the three laws. It is the proposed by the Asimov. So that's why we are calling this is the Asimov's law. And what is the reason for automating? So each and every industries, first of all, the first point is the safety. So because of the safety only, we are just first introduce the automation. So automation means to increase the labor productivity and reduce the labor cost, and then increase the quantity and increase the quality and everything to save the time. So that is the main important things, but the main reason to create the automation for safety. So what are the knowledge we need to work in robotics field? That means we are using different type of the components in robotics. Next I will explain about the different type of the what are the components we are using in robotics. So we need some knowledge from regarding the mechanical. That is the robotics is the multidisciplinary area like mechanical, and then instrumentation and electronic circuit branches, computer science and everything. So everything robotics is the basic, completely based on the classical physics. So we need about the electronics knowledge and mechanical like kinematics equation formation, and then we need computer for programming knowledge. So it is the multidisciplinary area. You can implement any kind of the technology like artificial intelligence and IoT cloud technology we are using. So any technology you can implement in robotics field. So first of all, what is robot means? The robot. So robot, we have that peoples they are telling they have different type of the robotic model. We have like Puma, Scala, articulated robot, and humanoid robot, a snake robot, hexapod robot. Like that, we are giving different type of the names for robotic system. But based on that, the first one is the fixed robot, and second one is the mobile robot. So basically, this is the two types in robotic system. So all robotic models, it will come under in these two types. The fixed robot, it is called the industrial robot. It will come under the fixed robot. For example, we have Puma. So Puma, it is nothing. There is the programmable universal machine for assembly. So this kind of the robotic model we are using in industrial manufacturing field. So we are giving different type of the names like material handling, loading and unloading, welding robot, spray coating robot. So lot of thing is there. So later we will discuss about the industrial applications also. So first one, industrial robot, we are telling this is the Puma. It is the programmable universal machine for assembly. And then is the SCARA. So SCARA is nothing. It is the selective compliance assembly robot arm. So this is the types of the industrial robot. We have the articulated robot. If we have the different types, but in Puma and SCARA, in SCARA robot maximum we are using in the labs, like chemical labs. The humans, they can't handle the some chemicals, so in that particular labs we are using the SCARA robot, and then we are handling the chemicals and mixing the chemicals. For particular application we are using the SCARA robot because it will handle the low payloads. So it will handle low payloads, but Puma, it will handle the high payloads. Payloads means nothing. We are using this kind of the terms in robotics. Payloads means it is the object's weight. So weight of the object, it is called the payload. So the Puma robot, it will handle high payloads, and the SCARA robot, it will use in some chemical labs to mixing some chemicals. A human, they can't handle the chemicals. So in the particular labs, we are using the SCARA. So this is the fixed robot. So what is mean by the fixed robot means? Fixed robot is nothing. The base is fixed. So this is the one of type of the fixed robot. The base is fixed. So that's why it can't move one place to another place. So it is like a fixed robot. That fixed robot, we have some different types like Puma, SCARA, articulated robot, different things. Okay. So the industrial robots, it will come under the fixed robot model, and then mobile robot. So the mobile robot, it will move one place to another place. So automatically we are giving different type of the names like humanoid robot, wheeled robot, hexapod robot, snake robot. So and then we are giving the name rover. So we are based on this kind of the robotic model. It will moving one place to another place. So this is robotic model. It is called the mobile robot. Okay, so this is all robotic model in this world. It will come under in these two types. So here next we are going to discuss about what are the components of the robotic system. So what are the components we are using in robotic model? So components, the first one, we are using joints, links. The second one, end effector, and third, sensors, actuators, grippers, controllers. So joints and links. So joints and links, okay. So joints. So we are calling this is the joints. The particular things it is calling the joints. So this is the one of the fixed robotic model. In the joints, we have the different type of the joints. We have the linear joint, orthogonal, rotational, twisting, revolving. So we have the different type of the joints model we are using in robotic system. For linear, it will move up and down. For left and right, forward and backward, the linear motions. And rotational, for in this particular motion, we have to identify the distance d. And then in rotational joint, we have to identify the theta angle. So lengths. So lengths means work envelope. That is the another important word. Work envelope. What is the work envelope means? I have some particular area. I am fixed a robotic model here. The robot model's base is fixed here. So what is the maximum distance a robot model it will cover? So based on your link length, you can decide the distance, the work distance. So it is called the work envelope. So based on the joints and links, you can design the program and then you can control the robotic model for your particular applications. So end effector, next one. So end effector means nothing. The end of the robot arm, it is called the end effector. So end effector, it will use to replace the gripper. Actually, we have the different type of the grippers. Next, I will explain. So now I have some particular application. In that application, I need one type of the gripper, and after that, I'm going to another application. So I have to replace the gripper. So automatically, with the help of the end effector, you can replace the gripper very easily. And third one is the sensors. So sensor is the very important part in robotics. Without sensors, there are no automation. So sensor, we are using different type of the sensors in robotic system, like obstacle sensor to identify the obstacle. When you are designing the mobile robot, I'm just using some sensors like obstacle sensor. I'm using IR sensor, ultrasonic, proximity. So this kind of the obstacle sensors, that is the obstacle sensor. I'm using the obstacle sensor. I'm identifying obstacle, avoid the obstacle, and after that I will reach the target in minimum time period. So this is called the obstacle sensor we're using. Like that, we're using temperature sensor, gas sensor, humidity sensor. So different type of the sensor we are using in the robotic system based on your applications. So I am designing my robotic system. So what are the sensor I need to create the autonomous robot? So what is my autonomous robot? So autonomous robot is nothing. The robot, it will take own decision and then it will move it will identify the path and it will reach the target without any interruption. So that is autonomous. So we are using without sensors, it's not possible to create the autonomous robotic system. So autonomous robot means we need different type of the sensors to identify the part. LiDAR sensor I'm using, and then avoiding the obstacle. To identify the obstacle, I'm using the obstacle sensors, and then I am just environmental condition for agriculture purpose. I'm identifying the temperature level, humidity level, and everything. So different type of the sensors is available. So touch and, for example, I'm using designing some robotic arm. That robotic arm, I'm just picking the object and moving one place to another place. I'm using the touch and tactile sensor. I'm fixing end of the robot arm. So automatically when it will touch the object, automatically it will give the information to the controller. The controller will control the motor substation. So the sensor is playing very, very important role in robotics. And third one, actuators. So actuators, we have three type of the actuators. So the first one is hydraulic actuator, pneumatic actuator, electrical actuator. So hydraulic actuator, pneumatic and electrical actuator. The actuator, what is in the meaning of actuator? It is actuating the system. That means it will help to move the robotic model one place to another place. So hydraulic actuator, it will work based on the fluid pressure. Okay, so if I am applying fluid pressure, it will handle high payloads. For example, JCB. So the JCB we are using in construction field, we are handling the very heavy stones and everything to move one place to another place. So that JCB, it's working based on the hydraulic actuator concept. Okay, so it will handle high payloads, but it's very slow. But pneumatic actuator, it is working based on the air pressure, the speed is high, but it can't handle the high payload. So it is the low payloads. It will handle low payloads only. An electrical actuator, it is a motors. Maximum 99% of robotic system we are using the motors only, servo motor, stepper motor. So based on your application, based on your process, you can select the motor type. So these electrical actuators, motors also, it will handle high payloads. Okay, so this is the three type of the actuators we are using in robotic system. So maximum we are using the electrical actuator only, that means the motors. So motors, we are using the robotic system, it will help to move the robotic model one place to another place. And for the next one is the grippers. So grippers, we have three type of the grippers. The first one is the mechanical gripper, and second one magnetic gripper, and third one is the vacuum gripper. So mechanical gripper, we have several types. One is 2-jaw, 3-jaw, hook, scoop. So this is all, we have different type of the models. So this is the mechanical grippers, the 2-jaw gripper, and then we have the 3-jaw gripper. So it will handle the heavy payloads items. So it will pick the object and moving to one place to another place. You can use this gripper in some Puma model, and then you can pick the high payload materials to move to one place to another place. So this is the 2-jaw and 3-jaw, hook and scoop. This everything is the scoop, very well in some ice cream shops. We are just one scoop of ice cream. That scoop also is the one of the mechanical gripper. So the next one is the magnetic gripper. The magnetic gripper, we have the two types. One is the permanent magnet, and next one is the electromagnet. So permanent magnet, the electromagnet, we need some external power source to generate the magnetic field, and then the permanent magnet not need external power source. But in permanent magnet, you can use the permanent magnetic gripper for low payload materials. Electromagnet, you can generate high electromagnetic field, and you can handle the high payloads. Okay, so this is the two type of the magnetic grippers. So and third one is the vacuum. So it is, very well, vacuum cups, it working based on this some air pressure. So you can handle some very soft materials like some Tetra Packs, for example, some Masa, some Tetra Packs company, or some biscuits handling the biscuits. So like the packets in manufacturers, they are using the vacuum cups. So glass. For example, I am now in glass manufacturing companies. I'm now handling the glass with using the robotic system. Now I'm using mechanical gripper. It is not possible to use, and magnetic gripper also is not possible. So in that time, I'm using the vacuum cups, and then I'm moving the glasses one place to another place. So based on the material type, you can select the grippers in your robotic system. So this is the different type of the grippers. And next one is the controllers. It is the controller is the heart of the robotic model. So controller is the heart of the robotic system. I have the controller. So I'm just receiving the information from the different type of the sensors. So I'm using different type of the sensors like a obstacle sensor, and then I'm using temperature sensor, humidity sensor. So anything, different type of the sensor I'm using in my robotic system. And after that, I'm just designed some autonomous robot. So in this particular robotic system, the controller, it will receive the information from the sensors, and then it will control your robotic model. So like in robotic system, we have the two substations. One is mechanical substation, and second one is the electrical substation. So mechanical part is completely, you're designing the robotic bodies. So you're just fixing the robotic bodies, the physical materials, everything. It is a mechanical substation. And the electrical substation is the motor. You can control the motor based on your information. You can increase the speed or decrease the speed. And after that, you can reach the target in minimum time period. So this is all the important components we are using in robotic model, and then you can design any kind of the robotic system based on your applications. So I have one particular application. I have to select each and every components. So what kind of the actuator I need, what kind of the gripper I need, what kind of sensors I have to use to create the autonomous robot. So based on your applications, you can develop the robotic system. And what is the industrial applications? So what are the industrial applications we are using the robotic model? So for example, I already told you material handling, material transfer, machine loading and unloading, spot welding. In welding option also, we have two types, spot welding and arc welding. So spot welding and arc welding, I have one metal here. Spot welding means the particular spot I will weld. So the particular points. But arc welding, I will cut the material. So we are using the two types of the robotic model, that is called the welding robot. And spray coating, assemble operation. So assemble operation, the car manufacturing company, that is the very good example for the robot automation, because they are using different type of the robotic model, and then they are implemented this all applications. So you are using moving the materials, and you are just painting the cars, and then you just assemble the parts, and then inspection robot is nothing. For example, some manufacturing companies, some cookies manufacturing companies, I have the cookie shape is circle type. Okay, so automatically what will happen, the inspection robot have the camera, automatically continuously it will identify using the image processing technology, using that is called the robot vision. So what is called the robot vision? So we have the computer vision. So computer vision means we're using the image processing technology, and then you're identifying the shapes, and then you're identifying some structure of the buildings and something. So using image processing, and then you're just analyzing the images, that is the image processing. You're using the image computer vision technology in robot, that is called the robot vision. So in robot vision technology, you're using image processing, and then you identify shape of the object. So automatically that is called the inspection robot. You are fixing camera, not that one only. So inspection robot is called the gas pipeline inspection. That means the human can't enter the particular hole, gas pipelines. So you are fixing the small kind of the robotic system I'm just developing. I'm fixing the camera. So automatically the robotic model, it will move the inside the pipeline, and then it will give the information to the centers. So this is the different type of the industrial applications. And then what is the non-industrial application? Not only industrial. The robotics models, it will use a lot of non-industrial applications also, like agricultural, constructions, and then entertainment field, healthcare. That is very important. In hospitals, they're using assist robot. So nowadays in Germans, are like other countries, they're using the robotic model for surgery also. So the healthcare and laboratories, I told you the SCARA robot, they are using in some particular labs, research labs. Okay, it will handle the some chemicals like that. And then in military, mining, transportation, so lot of non-industrial application is there. So the robotics is nothing for safety, automation. So using the robotic model, I'm creating the automation not only in manufacturing field, not only in any industries, non-industrials also, in hospitals also I can teach. In education, the teaching robot, and then exam invigilator also is there, invigilation robot. Okay, so you can use the robotic model anywhere in this world. Okay, so this is all the basic introduction of the robotics, and next video I will explain about the kinematics, how to write the kinematic equation for robotic motion. Okay, thank you to all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.